So here you can see that we have a code warrior working on, so we have to show that our RTC is working and how do we initialize it. So for the first part, as you can see here, this is our function, our initialize RTC. We have to enable the clock, which is the same as SGC6, and after we initialize the clock to the RTC itself, and then we have to set up the CR, which is the control register. SWR is the software reset. We have to enable the software reset so that it reset by is where it reset the RTC by itself when we initialize for the first time, and after we reset the RTC, we have to disable the reset part, and then after that we have to enable the oscillator. As you can see here, this is still in the control register, part of the control register, which is the oscillator enable. We have to use the 32.768 kilohertz oscillator, and then after that we have to use the SR, which is the status register. We have to enable status register. As you can see here, we end it with the TCE, which is the timer counter enable. We have to use the timer. We have to use the counter, which is the the time where the oscillator is running on. And then as you can see here, we have the RTC TSR. The TSR part is actually the time second register, so we have to set it into 0 so that we can start it from 0, and then after that we have to see on the RTC SR part, which is still the RTC status register, and we have to enable the TCE, which is the time counter enable, because we want to use the time from the TSR register and the TPR register. And then the final part where is the RTC IER. IER is quite interesting because IER is the most important part. Without this, the RTC doesn't work. IER stands for interrupt enable register, so is the interrupt itself. So we have to enable the TSIE mask. The TSIE stands for time second interrupt enable, and by enabling this, we can use the RTC by itself. So when we want to use the RTC, we have to just call initialize RTC in our main C function or other C file. So that's all for our initialize RTC part. So we'll be moving on to the next agenda. Thank you so much.
Use analog, combination of analog and digital. So this is an actual photos of our interface. So upper part is the analog clock, a perfectly working analog clock. Inside the analog clock itself, we have the day of the week itself. It's showing Monday. So under the analog clock, we have the digital 24 hours format of the digital clock itself. Is showing is 2 o'clock right now, and under the digital clock, we have the date itself. So everything is accurate up to the second in this interface. So on the 23rd November of 2015, the day itself is Monday, and it should be accurate whenever there is a leap year also. So we make a special case just for that occasion. So that's all for the clock interface. Thank you. To set up time and date for the alarm clock, first we have to press the center button on the Nokia LCD joystick, and there will be a menu popping out. Inside the menu, will be showing 4 things. So the first one will be the set time, set date, set alarm, set song, and the final is exit. So first we have to set the time for the clock itself. So by pressing the center button again, we can access the first menu, which is the set hour. So we have to press up and down so that it can run the number from 0 to 9. So if you press down, it will be running from 1 until 9, and then after you are done setting the hour, next we'll be moving on to the minutes. So for the minute, it's the same principle. You can adjust the minute by pressing up and down, so you can set from 0 minute up to 60 minutes. So sorry, 59 minutes, because 60 minutes would be 1 hour. So you can set from 0 to 59 minutes, and after you are done, you just press right, and we can access the set second menu. And inside set second menu is the same with set minute. So 60 seconds is equal to 1 minute. So by pressing up and down, you can set the second from 0 to 59, but normally we will set the second to 0. So just like that, we are done with setting up the second. So there is a curious question: how do we set the day for leap year? Because every 4 year we have a leap year, where on the February itself we have a shorter day, which is 28th day. So in this case, I'll be explaining in Code Warrior itself.
So we have our clock algorithm function running on. So this is one of the function that govern on how the alarm clock or the basic clock works. So here, as you can see, this is how we configure the second, the minute, the hour, but we cannot configure the month the same as how we configure the hour, minutes, and seconds, because every month is a bit different. Some of the month has 30 days, and some of it has 31 days. And during leap years, some of February especially has 28 days. So how are we gonna solve that problem? So first, we group up all the months that has 31 days into one function. So all this month has 31 days. So when it reaches 31 days, it will reset itself. The month will +1. So let's say from January it will come February, and the date will reset itself from 31st of January to 1st of February. So done with all that, then we have to configure a month that has 30 days. So we configure them into one single line like this, and the same as above, month will +1, date will reset itself into 1. But there is a bit special for February, because February, when it reaches onto leap year, the number of days will come from 29 to 28. So we have a function here, we have a line here that states when the year is leap year, the date will be 29. The day is 29 days, and when it reaches more than 29, the month will +1, the date will become 1. So when it's not leap year, it will become 28 days, and the month will +1, the date will reset itself. So let's say after the whole year, which means the month will become 13. So when the month is become 13, which means it's a new year, so we have to change the year +1, and the month will reset itself to 1, and the day will reset itself into 1. So it becomes from 31st of December 2016 to 1st of January of 2017. Becomes something like this. So that's all on how we configure our clock system, clock algorithm.
So to set the date and year and month, we have to exit the menu, and we have to go back to the main menu, and from the main menu we have to press one time down so that we can access the set date button. And press the center button and we go inside. So it's the same as set time just now. We just have to scroll through the year that we want, the month that we want, and the day that we want. So after we are done with that, we just press the center button again and it will bring back you to the main menu. So from the main menu, if you want to set alarm, you just have to press down and center again. And once inside, there's three options that you can choose: set alarm, switch on alarm, switch off alarm, and exit. So if you want to if you want to switch on the alarm, just press center again, and inside the switch on alarm, you have to set the time itself. So it's the same principle as how you set the time for the basic clock. So you just have to select the time that you need, and when you're done, you just have to press the center button and it will bring back you to the main menu again. Additional features that we put inside the alarm clock itself is additional song that the user can choose from. So instead of one song, we given the user more flexibility to choose from three songs. The first song will be a Twinkle Twinkle Little Star, second song will be a marching song, and the third song will be a Jingle Bell. So we come across this question, what is the controller doing most of its time? So in how we program it, the controller is actually running the basic clock. So this is the job of the controller most of the time, is just run the basic clock until infinity, until there's an interrupt from the RTC or the FTM that require the alarm clock to ring.
So we have to determine on what is our system frequency. So especially for the FTM part, the system frequency that we are going to use is 3 megahertz. So how do we get 3 megahertz? So as you can see here, we have to define our system clock frequency as 48 megahertz. The 48 megahertz is actually the clock built into the controller itself. So we have to use a prescale value to further enhance or further scope down on the type of frequency that we want. Either we want a high frequency or a low frequency. So we are using a prescaler of 4. So 2 power 4 is 16. So you take 48 megahertz, 48 times 48 megahertz divided by 16, it will be 3 megahertz. So the clock frequency that we are using in our the system frequency that we are using in our project is 3 megahertz.